All right, so we are on the Chapter 8 review sheet, doing problem number 1, which says find the points of intersection. When we are finding points of intersection, regardless of what the equations look like, we're going to think about substitution or elimination. So when I look at this, I want to know where this line, this is a line, where does that line intersect this ellipse? Anytime I'm looking for intersection, I'm going to think about substitution and elimination. Since these are not squared and these are, elimination probably is not my best thing this time. So my best move is probably going to be just to substitute. So I can take that top equation and set x equal to 1 minus 2y. And then I'll plug that right in here. So I have 1 minus 2y squared plus 3y squared equals 2. Right? Now what? FOIL, yes, absolutely, FOIL. So 1 minus 4y plus 4y squared plus 3y squared. Oh, I do not like the looks of this. So 7y squared minus 4y minus 1 equals 0. I really do not like the looks of that. Did I make a mistake, or is that the way? Is that right? Okay, well, all the world is not integers, so I'm getting a dose of my own medicine here because that does a factor, which means what are my y's going to be? How am I going to find y? I can use the quadratic formula. Josh, or Zach?
How did you get rid of that? You subtracted over. Oh, okay, never mind.
So y equals, here we go, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that is that 44? Yeah. So square root of 44, that would be 2 root 11. And I can pull a 2 out. And here we go. Look at this disaster. I have 2 y values. One is this, and one is this. Now, why am I writing it this way? Because what was my job? What am I looking for? Points of intersection. So my answer is going to be points. And now I have the y coordinates. So now I'm going to go back and now I'm going to figure out what the x's are. Right? So x equals, I'll do one at a time, x equals 1 minus 2 times 2 plus root 11 over 7. I'm doing this one first. So that's going to be 7/7 minus, let's do it this way, minus 4/7 minus 2 root 11/7. If I take 2 times that and 2 times that, so what is that?
3 minus 2 root 11 over 7.
Yep, there you go. There's your x. Now maybe I can do the second one without much more work. Change this to a minus. It's going to make that a plus. So will that be 3 plus 2 root 11 over 7? Done. Yuck. But that's it. Okay, don't get bogged down in the arithmetic. Do you see the big picture? We're finding where they cross. We need to do substitution or elimination, right? And hopefully I planned the test question better than I planned this one. All right, what else? Look on the paper. What else? what else do we need to do? We're gonna use this time, kids, so you might as well engage here and let's get some, because next time I see you, we're taking a test over this.
Well, I have a question. Like, hyperbolic, take the vertices and then give us 1 point, like on the actual hyperbolic.
The questions will be like these. So are there questions on there like that?
No, but it was on the homework side.
Okay, no, this is the test. All right, who else? Come on, there has to be something on here you feel uncomfortable with. What are you scared of? I'm going to set this in front of you on Wednesday. What do you think you're not going to be able to do? Which one? Did someone say something?
So like, can you do one like when there's like 2 answers for the circle?
Okay, can you find a question on this review sheet?
You do 3C.
3C. These are the expectations I have of you. So let's look at 3C. So it is an ellipse, so I'm going to go ahead and set up my equation. I'm writing my equation, and it's an ellipse, and it has foci at -1, -2 plus root 13, and -1, -2 minus root 13. All right, so these are my foci, and a major axis that's 10 units long. Okay, now I know the ellipse opens like that because my foci are always on the major axis, so I know this is the major axis. I also know it's 10 units long. Okay? Alright, so what, I've got basically 4 spots to fill in this equation. Can I fill in any of those?
You put 25 under the Y.
Under the Y, I can put 25 because I know the major axis is up and down. I know it's 10 units long. I'm going up and down. 5? Done. All right, what else can I fill in?
You can put 12. Is it 12 under? No.
I don't know, but
Because 13.
let's get the center taken care of. Isn't the center going to be the midpoint of these?
Yeah.
Where's that center going to be? -1, comma,
-2.
-2? So x plus 1, y plus 2. Now, how far up and down did I go, center to focus? How far up and down did I go when I plotted these foci? Root 13. And I know in an ellipse, if I take the square root of the big one minus the little one, and I know that's the big one because that's the major axis, I have to get root 13. So somebody said, is that a 12 under there? And it is a 12 under there. Right? All right, who else that was it, right? That's all I had to do was write the equation. Yep. All right, so who else had a question? See something on here that you're feeling a little bit shaky about Wednesday? Okay, well, I can see 2C, I got tricky. Tell me about 2C. That's a circle. We know that's a circle. We don't have to do the discriminant. Why do I not have to do the discriminant there? And there's no XY term, right? When there's no XY term, then you know the rules. So that one's kind of tricky. All right, let's do, I was going to randomly pick something here. Let's do 5E. Let's write the parametric equations of that vector. or that line, I mean, not that vector, right, the parametric equations of that line. So we're gonna do 5e. Our points are negative 1, 1, 4, and 2, 2, 7. So I want my parametric equation, so this will ultimately be my answer. I'm going to start by writing the vector form. You do not have to do this. This is my personal preference. It's going to tell me what x, y, and z are all together, and then I'll split them up. So what goes here? Negative 1, 1, 4, or 2, 2, 7. And what goes here? Not 2, 2, 7. What goes here? 3, 1, 3. Yep, that's exactly right. How did we get 3, 1, 3? That's the directed distance, the vector coordinates from this point to this point. So then x equals negative 1 plus 3t. Just look at the x parts. And then y equals 1 plus t. And z equals 4 plus 3t. Everybody okay with that? B, 4B is a little bit tricky. 4B. It shouldn't be because circles are normally the easiest. What makes 4B a little bit trickier than some of the other circles we've looked at? There's a coefficient. Now you can handle that coefficient however you want. Since it's the same 2, you can divide the whole shebang by 2 right off the bat, if that's what you want to do. You could also treat it like you do the ellipse and the hyperbola and factor it out of the x's and the y's. But if you do that, eventually you're going to have to divide it out. You're going to have to get rid of it in order to find your radius. So I'm just going to do that right now. I'm just going to get rid of that 2. You don't have to do this, but I am going to. So I took my x's and I'm dividing everything by 2. And then I rearranged. So my x's are together, my y's are together. So I'll put a 1 here. Oh boy, oh boy. What completes the square here? Half of 3 is 3 halves. And 3 halves squared is 9/4. All the world is not integers. We have to deal with it. So now we got to add that up. So that would be 14 fourths, 4 fourths, and 9 fourths, which makes a grand total of 27 fourths. I need my center, my radius, and my eccentricity. The eccentricity is 0. It's a circle. Where's my center? 1 negative 3 halves. What's my radius? Square root of 27 fourths, which is 3 root 3 over 2. Square root of 27 over the square root of 4. Alright, so that was a little tricky. Let's see what else. How about 3a? We haven't done one of these today. Write the equation of the parabola. with a focus at 3, -7, and a directrix at y equals 9. So we're going to write the equation of the parabola.
It's y squared.
Okay, so remember, with a parabola, you've got something squared equal to this 4p number times something not squared. This is the focus, that's the directrix. Can you tell this guy opens down?
Yeah.
When it opens down, what is squared? X. Not only that, but this guy has to be negative. That 4p number will have to be negative. The vertex will be right in the middle of the focus and the directrix, right? Because you go up so many and down so many. So that's going to be at the point 3, 1. Now the 3 goes with the x, the 1 goes with the y. The only thing left to find is that coefficient. This distance we call p. So in this problem, p is big. What is p is 8? If p is 8, then 4p must be 32, but it's negative. We already said that, because we're opening down. Remember, the distance from the vertex to the focus is p. That's always 4p. All right, you do not have to finish this review sheet. You are welcome to. The answers are provided. You do have to, on Wednesday, turn in the 2 practice tests, one of which we have completed.